All right, this is just a quick example for solving equations using waves and sound. So basically, what we've got here is it says there's two ducks that are floating in water off the coast of Fuji, where the air temperature is an amazing 28 degrees Celsius. This will come into play a little bit later. An observer on shore notes at what time, when one duck is at the top of one crest, so the top of one crest, and the other duck is in a trough, there are exactly two crests between them. The observer measures indirectly that the ducks are separated horizontally by 60 meters, and also records that the ducks bob up and down 30 times in 2 minutes. So they're separated by a distance of 60 meters, and so there's quite a bit of information in here that we're going to make use of. So one of the first things that we're going to do is we're going to look at what's happening right about here in terms of the sketch for this. So we're going to draw a wave to simulate the situation. Okay, like so. And it says that there's the two ducks, and so it says that one duck is at the top of a crest. I can't draw a duck. There we go, that's a duck. All right. And the other duck is exactly two crests between them, and he's in a trough. So here's one crest, two crests. So the other duck is way down here. Now, it was measured that it was 60 meters between the two of them. So that is from here all the way to here. That's 60 meters. So one of the first things we're going to do is try and figure out what's the wavelength. What is the wavelength for one wave? So if we're here and I draw one wave, that's one wavelength right there. And then I can draw another wavelength to there. And then the last one is right down to here. So what you'll notice is that we've actually got a series of, we've got a wavelength from here to here. We've got a wavelength from here to here. And from here to here, we have half a wavelength. So in total, we know that between the two ducks, there are 2.5 wavelengths, must be 60 meters. So the question is, what is the value of the wavelength so that when you multiply it by 2.5, you get 60 meters? So we can do that very simply by just saying that the wavelength therefore must be 60 meters divided by 2.5. And that will tell us the value for that. So the next part is the frequency. Well, it tells us in the question that the ducks bob up and down 30 times in 2 minutes. Well, that's 30 cycles in 120 seconds. So that will give us a measurement in hertz. So we know our wavelength, we know our frequency. So the last part is find the speed of the waves. Well, speed is frequency times the wavelength. So the frequency was 30 over 120 times 60 over 2.5. You can put this in your calculator to get your result. Or you can, there's different things you can do. So we'll just put this in our calculator to get our number, and then we'll look at the second part of this equation. So let me just do that. You probably just do it in your head. 30 times 60 divided by 120 divided by 2.5 gives us 6 meters per second. So that's the speed at which the waves are traveling. In the next part, we're going to find out one other piece of information. So there's an observer that's 1.2 kilometers away from the ducks. And the duck quacks really loudly, and we're asking how long does it take for the observer to hear it. Well, we know that speed is distance over time. So we want to find the time, so that's just distance divided by speed. Well, the distance is 1,200 meters, but the speed we don't know. But we know that we're talking about sound. So it's the speed of sound. Well, the speed of sound, and if you recall back to work that we did before, the speed of sound is 332 meters per second, and then we factor in the temperature at 0.6 T. So in this case, the temperature was 28 degrees. So the speed of sound is a little bit faster in this situation than it is at 0 degrees because the air molecules are moving more quickly. And so we get about 348.8 meters per second. There we go. Now what we do is we simply take the 1200 and divide it by 348.8, and we end up with about 3.4 seconds. So it takes 3.4 seconds for this loudly quacking duck for that sound to travel 1,200 meters or 1.2 kilometers. All right, that's it.